So that is called a scalar product, right, Faz?
Yes.
And when we multiply vector with vector and we get another vector. So this is called the vector product or the cross product. And what are the rules for this cross product? So this is how we get the cross product. Okay, when we multiply A with B, so this part AB sine theta tells us about the magnitude of that cross product. And this n cap or n hat tells us about this direction of this cross product. Because ultimately A cross B is what? Yes. A cross B is a vector quantity. Right, Afaf?
No, I didn't get it.
Yeah. Okay. So I'm saying that when you multiply. Okay. So let me. Yeah. So when we multiply a vector into vector and we get another vector. Right. So this is called the cross product. Right, Afaf?
Yes.
So let's say multiply A with B, and this is equal to AB sine theta.
Sine theta.
Right. So this
Yes.
part has any. Does this part have any direction? Yes.
Yes, it does has, because since cross product is a vector, so it has direction.
Yeah, it has direction, but up to this point, do any of these terms have direction?
No.
No, right? So this part is only the magnitude part. So to make it a vector, there must be a direction. So this n hat represents the direction of that cross product. Okay. So A cross B will give you AB sine theta and this n hat. So now this completes and this tells that it is a vector. Understood?
Yes, I understood.
Yeah. And how do we get this direction of this n hat? So this direction of the n hat, we get this by using the Maxwell right-hand thumb rule. So you remember what was the Maxwell right-hand thumb? So if we point our palm in some direction and then we curl our palm, so whatever the direction that our thumb gives, so that is called the Maxwell's thumb rule, right? Yeah. Do you remember that? Yes.
No, so Maxwell's right hand rule, I don't.
Oh, okay. So we calculate the direction of this n hat using the Maxwell right-hand thumb rule. And what is the Maxwell right-hand thumb rule? So if we place, so this is our A vector. So if we place our palm in the direction of the A vector, right? And then you have this B vector. So then we go to this B vector, right? Then we curl our palm in the direction of the B vector. So you can see that my thumb is pointing in some direction, right? Right, Afaf?
Yes, you're right.
Yeah, so this thumb points out to the direction of that A cross B. So this
Direction, yes.
Yeah, so that is how we get the direction of that cross product.
Right. Okay.
And this is coming into the plane or coming out of the plane. This thumb.
Into the plane.
So this is not entering into the plane. This is coming out of. This is outward.
Oh, yeah. It is coming out of the plane. Yes.
Yeah, this is outward, right? So we have the structure of the arrow, right? Is like this, right? This is tail,
Yes.
and this is the head. So when the arrow, let's suppose that when the arrow is coming towards you, So what part you will see, this or this? Yeah, the dot. Yeah.
The dot.
So yeah, so let's assume that the arrow is coming at you, right? So yeah, let's you have a pen, right? So you take the pen and suppose that the pen's nib, right? Pen's nib is coming at you. So what you will see, this dot or this cross?
The cross.
Okay, you have this pen, right? And this is the nib. And this shows that this pen is coming at you. So you will see the dot or the cross, this one or this one. You will see the dot, right?
We'll see the dot.
Right. So
Now,
this,
yes.
yeah, so this direction shows this sign. This sign shows the outward direction, right?
Yes, it shows outward
And
direction.
and when the arrow is going away from you, so when the arrow is going away from you, so then you will see the cross part of this arrow, right? When you see the arrow from the behind. Is that clear?
Yes. Yes,
So
yes.
this shows the inward direction.
Inward direction.
Okay. And yeah, so why do we need these signs, right? Because to represent the direction on this play in this 2D, the upward direction and the outward direction, so we need some different signs, right? Because we cannot represent the direction on this play. Understood?
Yes, I understood.
So that is why we need this point and this cross sign. So here you see that A cross B is pointing, the thumb is pointing towards outward direction, right?
Yes, it's pointing outwards.
Yeah, so that is why you see this direction. So this is the n hat. Is that clear?
Yes, that's clear.
Okay, so now then we talked about this I cross I. So we have this I cross I, and we know this already. A cross B, we know that this is A, B sine theta and n hat. This we know. So I cross I would be how much from this analogy? Yeah. Yes, Safa, you tell me.
A vector into base AB sine theta.
Yeah, A, B sine theta. So what is A and what is B in this case?
I and
Yeah. I magnitude and I
I
magnitude.
magnitude, I magnitude.
And what is the angle between A and B, I and I? Yes.
Sine theta.
Yeah. What is this theta?
Yeah.
So you are calculating
45.
angle. Yeah, you are calculating the angle between I and I. So this is the same direction, different direction, or what direction? Any other direction?
They are in
Same.
same direction.
So same direction. What? So what is the angle when you move in the same direction?
180.
Okay, and when you move in the different direction, so what is the angle? Yes. So you have two arrows, right? Two rays.
Different direction,
and-
I don't know.
Yeah. So when you have this I direction and we go to the I same direction, so that would be the array or the ray are making what angle? We have two arrows, right? So this is some angle. This is 90-degree angle. This is let's say greater than 90-degree angle, and this is 180-degree angle. So what about this angle? This is 0-degree, right?
0 degree.
Right. So this is 0-degree. So I and I makes the 0-degree angle. Right. So
Okay, so
theta
if
would,
it's if the vectors are
yeah,
same direction, it will be 0 degree.
yes, yes, because the rays are in the same direction, right? So this will make 0 degree angle. So sine theta, theta is 0, so sine 0. And sine 0 is how much? Yes,
0.
0. So this cancels out, and I cross I gives 0. Similarly, we have this j cross j, because j cross a sine 0 is again 0. And similarly, we have this k cross k. So do you remember what happens in the dot product? What is I dot I?
Assalamualaikum.
Oh,
1.
walaikum assalam. Yeah, so yeah, you came at the perfect time, because we didn't go ahead and we are just revising the cross product, right?
Thank you, sir.
Because, yeah. Okay, so what is I dot I? Okay,
1.
Akif, 1. Okay, so Akif just came, so I wanted to ask this to Akif. Okay, so yeah, and we see that I dot I is 1, but I cross I is 0. Okay, and
Yes.
let me ask you that what would be I cross?
I to j.
0.
I was asking this one.
I cross j is 0, Akif?
Sir, because if we multiply 2, like, how should we say? 2 I cap into I cap, then it will be 1, right? So
Wow.
it is different. So 0.
So can you? Yeah, so okay, so this is cross product or dot product?
Cross.
Cross. So for cross, we have sine theta or cos theta.
We have sine theta.
So, and I dot j is 0. This is I dot j is 0, right? Because cos 90 is 0.
Yes, sir.
So I cross j is 0. How did you reach this answer?
Just like how I cap into I cap is 0.
Yeah,
So I
I
thought
cap.
I cap into J cap, so it will be 0.
This would be sine. What is the angle between I cap and j cap?
I cap and J cap 90 degree.
90 degrees. So this is 1, this is 1, this is 1. So how can this be
1.
0?
It cannot be 0.
Right? Yeah, it should be 1. So revise, Akib sir, revise. Okay, but this part is only the magnitude part, right? What would be the direction of I cross j?
K.
K, right? So K. So I cross j would be K. Is this clear, Afa? Yes,
Yes,
Akib.
sir, it's clear.
Yes, sir.
Yeah, so we discussed this in the previous class. So similarly, I cross K would be how much? Afa, you tell.
I vector into k vector sine.
Magnitude,
not
magnitude. Sine.
I
And what is the angle between I and K? So I have represented in so many ways that what is the angle between I, example of room, and then I showed some 3, 10. So what is the angle between I and K?
mm,
Again, forgot. So then I need to take out the 3 pens. So do you guys remember that I showed
180.
that 180?
No,
Yeah,
no,
Akib,
not 180.
one time
Seven.
Akib told me that it is 180. So yeah, Akib, what is the angle between I and K?
I and K 90 degree.
90 degree. Okay, now you remember it properly. So Afaf,
Sir, how is it 90 degree?
okay, so then I need to bring out 2 more.
I cap into j cap will be 90 degree. I agree, but how k?
Okay,
Look from
so
down part.
yeah. So we have, let's say, Okay. I can show this way. So this is I, right? This is I, this is J,
Yes.
and this is K. You see?
Yes, sir.
So what is the angle between I and K? Yes. What is the angle between I and K? Afar. Or you can just
It's 90 degree.
90 degree, or you can just watch your room, right? So just corner of your room. So in the floor part, in the corner, you have this I, and then you have this J. And then the roof part, or the which is the wall part, so you have this height. So this is K. So you can see that what is the angle between I and what is the angle between K. So 180 or 90 of
90.
90. Okay. And then this part is the magnitude part. But what would be the direction? I cross K. What would be the direction? So if you have this is I, right? And this is K. So you are going. Okay. Well, how should I? So this is right. Okay. So then I need to, yeah. Yeah, you guys tell me what would be the direction of I cross K?
J.
J or what?
J cap.
So J cap or minus J cap? Yes.
My
Yeah. So J minus minus J. So Rishita answer is minus J. And Akib,
So I should is 0.
zero direction. How can the direction be zero?
Then sine 90, it is 0, right?
Sine 90 is zero. And what about
Wait,
cos
sorry.
90?
Sine 90. Yeah, sine 90 is 1.
Yeah, this is one. And then you have this direction. So what would be the direction? I don't have 3 pens right now. I have to move somewhere else, and then I need to show you. So you guys think about that, why this would be minus J. Yes, Rishita's answer is correct. So you guys think about that. This is I, this is J, and this is K. So you are going, how should I? So you are going, right? So this way. So that is how this is I cross K would be minus J. So you guys think about that. Akib and Afaq, understood why this would be minus J?
Yes, sir. Now understood.
Yeah. So you take your palm in the I direction, and then then you curl it into the K direction, and then you will see that what is the direction that it points out. So yeah. Let's say this is I, this is J, right? And then this is K. So you are going in this way. So which direction it's, so this is J and this is minus J. So you see that what direction it points out. So you are going in this direction. So minus J. Understood? So if you go to the right, so yeah. So that is how it is pointing towards this minus J direction. Is that clear, guys?
Yes, sir.
Okay.
Yes, sir. It's clear.
Yeah. So we have this cyclic diagram that represents. So we have this I, J, K. So if we go into I cross K, so this would give me K. And if I go to J cross K, so this would give me I. So when I calculate I cross J, so this would give me K. And when I calculate J cross K, so this would give me I. And when I calculate K cross I, so this would give me J. This is called the cyclic property.
Sir, can you scroll up?
Oh, so which part are you noting it down?
Yeah, this.
Yeah, so just write that this would be minus j. If I would have
Yes, sir.
those, yeah, if I would have those 3-pin structure, then I could have shown you easily. But yeah, you guys check that and why this should be minus j. Okay, so this is the cyclic property from which you can easily understand what would be the cross product, different cross product. So I cross j, right? This is a clockwise or anti-clockwise, guys? Yeah,
Clockwise.
clockwise. So when you go clockwise,
Clockwise.
yeah, when you go clockwise, so that would give you positive. Clockwise would give you positive, and when you go anti-clockwise, so that would give you negative. Right. So when you want to calculate I cross j, so that would be minus j. So this diagram is important, guys. So just note down this diagram. And then I will talk about this differentiation. And so you all have maths, right, guys?
Yes, sir.
Yeah. So did you guys reach the limits and continuity? Did you guys reach that portion?
No, sir.
No, sir.
Okay. So then partially I will talk about this differentiation and integration. Okay. So whatever part we need for our purpose in physics class, so I will talk about that. Yeah, noted this part.
Yes, sir.
Okay. Rishita and Afaf, noted.
Yes, sir.
Yes.
So then we will do 1 or 2 questions and then we will go ahead. So let's say that A is 3i plus 4j and B is 2i minus 5j. So you guys, oh, let me write it as, okay. So A cross B would be how much? This would be 3i.
3i plus 4j into 2i cap minus 5.
Okay.
Right. So this and this will give you how much?
1.
I cross I. This is not.
5i. 6i.
Oh, I cross
6i.
I. Rishita, and Afaf and Akib. So just remember.
Sorry.
I
0.
I cross I. Yeah. Just remember that
0.
this is just the opposite of the dot product. So in the dot product, only the I dot I, the same ones survive. I dot I, j dot j, k dot k. Only the same ones survive. But for the case of the cross product, the same one will not survive, only the different ones will survive. So we will have this, so I cross I would be 0, right? And then we have this 3i cross 5k. So this is minus 15 and I cross k is how much? I cross k. Yes, guys. I cross k. Yes.
1, sir. Minus j.
Minus g. Yes. Minus g. Yes, Akib. Is that correct?
Yes, sir.
Yeah. So this part is clear. And 4j cross 2y. So plus 4 into 2 is 8. And j cross I. J cross I is how much? Akib.
J cross I, K.
Yeah, plus or minus?
J minus.
Minus, right? So minus k. And then we have this j cross k. So minus of 20 J cross K is how much, Rishita?
So minus I,
Oh, J cross A, J cross K.
I.
I,
can.
right. I can. So, yeah. So then we will have minus 20I and plus 15J
Plus 8 plus
and
15
minus
J
8.
cam minus 8 K cam.
So this is our A cross B. Understood, guys?
Yes.
Yes, sir.
And
Yes, sir.
yeah, you guys quickly note it down, and then I will give one question, and then I will talk about that calculus part.
Done.
Done. Okay. Rishita and Akib.
Yes, sir.
Yes, sir.
Okay, so you guys have already so many homework. So you guys try this question. So let's say A is 2I plus 3J plus 4K, and B is 5I minus 3J plus 2K. So what would be A cross? So you guys note it down and yeah, try in your home. Okay, guys.
Yes.
Yes, sir.
Okay, so now let us. So this part is clear. Vector part is finished.
So can I just copy the question?
Yeah.
Sir, I just have a question. Like in the previous question, you multiplied I cap with J and I cap, yeah, 3 I cap with 5
Yeah.
also. So in this question also, we have to like
Yeah,
multiply
same.
each vector with each vector.
Yeah. Only have that you have one more term here. So
Yes.
yeah, there would
So like
be
here also in this 2 I cap multiplied with 5I minus 3J and 2K like that.
yeah, like that. But I cross I will not survive, right? So J cross
Yes.
J and K cross. Yes, absolutely right.
Okay. Okay, sir.
Okay. So the vector part is finished, right? And in vectors, what did we learn? That whenever we have this direction involved, so then we have to understand about this. Then we have to take care of this vector part, right? We have to take into consideration the direction also. And then you represent. So then how do you represent a vector? You represent it with some magnitude and then direction, right? So the first thing we learned that you have this vector, right? So this length represents the magnitude and this represents the direction. So the direction of this vector is A, right? This is called the unit vector. And then secondly, you learned about this Cartesian form of the vectors. Right, in the Cartesian form, you understood that we can write it in the rectangular coordinates x, y, z, and we divide x as unit direction. So this is called I hat, this is called j hat, and this is called k hat. So we can write any position. Let's say this is x, y, z. So my position vector would be x, I, y, j, and z, k. So similarly, we can write any vector as x component, y component, and z component, right? And then we calculated the magnitude of this vector as this and unit vector by dividing the vector with the magnitude. So this we learned in the Cartesian coordinate, and then we move on to the okay, and then we used some property of the Cartesian form. So addition and subtraction we did. Right. So this we learned, this was pretty easy, right? This we just add I with I and J with J and K with K. But
Yes,
then
sir.
we understood about this polar form. right? In the polar form, we learned that whenever we have two vectors and the angle between them is given. So then we use this parallelograms law, triangles law, and something like that. And then we calculate the magnitude. So this is A plus B resultant. And the magnitude is simply the angle is B sine theta divided by A plus B cos.
A plus B cos theta.
Yeah. And then we also did this subtraction of vectors. So for this, we found out. Yeah.
So underscore A square minus B square.
No, plus.
Square minus 2AB cos theta.
And the angle was
B sin theta by A minus B cos theta.
right. So this we learned in the polar form. And then fourth one, we learned about this resolution of vectors. So in the resolution of vectors, we understood that we can write any vector which is theta in the rectangular form, right? In the rectangular form, meaning x component, y component. So this is A. So the x component would be A cos theta. Y component would be A sine theta. Right, so we can write our A vector as AXI plus AYJ as A cos theta I and A sine theta J. So I gave some question on this resolution of vector, guys. So did you guys do that problem? You had some so many vectors. These kinds of vector were there, and I asked you to calculate what is OP plus OQ plus OR, something like OS. So do you guys remember this question?
Yes, sir.
But you guys, so did you guys try that question?
Yes, sir, did.
And did you get the answer?
Yes, sir.
Okay, so why didn't you send me the answer there? Okay, so this was the resolution of vector. And then we also learned that when we have three coordinates, right? When we have this 3x, y, z, and this vector is making alpha angle with x coordinate and this beta angle with y coordinate, and then gamma angle with the z coordinate. So then we learned about this. Yeah. Oh. Okay, no problem, Aki. Yeah, no worries. So yeah, Rishita and Afaf, did you guys try that question? This question? No.
No, sir.
Okay. Okay. So at some point later, yeah, in the NEET and JEE part, I will do that question. Okay. So then we learned that. Oh, okay. Okay, Akim. Okay, got that, sir. Okay, so AX would be how much? This is A. So A cos alpha and AY would be A cos beta and AZ would be A cos gamma. So then we learned that cos square alpha. So these are called. So cos alpha would be AX by A, cos beta would be AY by A, and cos gamma would be AZ by A. So these are called the direction cosines. And this is the relation between the direction cosines. So this we learned in the resolution of vector, right?
Yes, sir.
And then we understood about this dot product. Dot product A dot B was simply AB cos theta, right? And we have A, which is AX, I, AY, J, AZK, and B, which is BX something something. So A dot B came out to be AX, BX, AY, BY, and AZ, BZ. So this we did in the dot product, and we also did this projection of vectors. So projection of vector A on B. So this was simply, yeah, who remembers? Akib,
Yes, sir.
what was the projection of vector A on vector B?
Projection. Yeah, AB cos theta.
Okay. AB cos theta, that was actually A cos theta, and we represented that by B hat and B hat. So
Yes,
this
sir.
was, and similarly on B on A was B dot A or and A hat, right? And then
Yes, sir.
we learned about this cross product. So in the cross product, we learned that A cross B is simply AB sine theta n. Okay, so
Yes,
this
sir.
much we had learned. This was a quick revision of whatever we have learned so far. Now comes the calculus part, right? And in this calculus, we have two major portions. One is this differentiation, right?
Sir, vector finish?
Yeah, vector is finished.
Alhamdulillah. Okay.
Okay, so we will complete this calculus part quickly today, hopefully today, and then I will start from the first chapter. So you guys have completed this vector part and the calculus part. So then all the chapters would become easy for you, right? Because these were the major portions that come in the first, second, not the first, but second, third, and so on chapters. Okay. So, but before we learn this differentiation and integration, let us understand about some special function, right? So first, what is a function, right? So let's say you have some variable, right? X and some other variable which is dependent upon X, so that would be called Y, and that would be some function of X. So this X would be called the independent variable, and this Y is called the dependent variable. And how can we relate this Y from X? And this we can relate it with this function. Right, guys?
Yes, sir.
Yeah, so let's say I have a straight line, right? So what is the function that we represent with this straight line? So how do we represent a straight line? Yes.
Yes, sir.
How do we represent? What is the function that represents the straight line?
Function.
Yeah, what is the function that you guys have all maths, right? So function is the first chapter.
For what,
Yes.
sir?
Forgot. Rishita and Afaf, you guys, do you guys remember?
So sine theta. That's
Sa-
function.
Sine cos, so that is, so sine cos is this one. This is sine
Sir,
and
can you
this
repeat the
is,
question again?
I'm saying that what is the function that relates, let's say, this straight line. So how do we represent this straight line as function of, let's say, this is x or y? Oh, this you already did this in the 10th.
Modulus function.
Modulus function is this one, right? This is y equals to modulus. This is what? So you can see that for this case, whatever is the value of, let's say 0, let's say this is 1, so this would be 1. If this is 2,
Sir,
so this
identity function.
identity function. Identity function. What is an identity function?
Like x is equal to y.
Oh, so yeah, y
So
equals to,
0 is 0, 1, 1, 2, 2.
yeah. So this is the function of a straight line, right? For this case, where your origin is 0 and then intercept is 0. But the general form of the straight line
Constant
is,
function.
this is the, yeah, do you guys remember this equation?
Yes, sir.
Where m is a slope and this is the constant. Constant function is this, right? This is the constant function. Okay, so forget about that. So, yeah, say straight line is represented by y equals to mx plus c. Okay, so where this is, let's say, this is your y-intercept, this is your x-intercept. So at x equals to 0, y is c. So this is your c. Right, this is your c and m, straight line. Is that clear, guys?
Yes, sir, it's clear.
Yes, guys, is that clear? Yeah. So this represents a straight line, and then you have this trigonometric functions. So I'm talking about some special functions. Right. And you have this trigonometric function. So in trigonometric function, you have this sine x and y equals to sine x. Right. And then you have this y equals to cos x and so on. And then you have this exponential function. So this is represented by Ex. Okay. And then the last one which we will use is this logarithmic function. So logarithmic function is represented by, right. I will not talk about in the detail of this function. So what is the base and how do you, right? So I will not talk about it in detail. So just you guys just remember all these functions. Okay.
Yes, sir.
Yeah. So you will see that the exponential function is described by this, and this logarithmic function is described by this. right? And sine cos, you know, so sine is this one, and the cos one is start from 1 and then something like this. So these graphs you should remember, right? So in the function part, you guys learned about this graph. Did you guys learn about these special functions?
No, sir.
No, sir.
Oh, okay, so just remember that these are the functions, special functions. Okay,
Yes, sir.
okay, and we have this differentiation. So you guys understood that what is a function, right? In function, you have this dependent variable and then independent variable, right? So right, so let's say you have y, which is function of x. So if I change this x, right? If I change this x, so this y will also change, right?
Yes, sir.
So let's say that if let's say this is 3x squared plus 5, right? So let's say if I write x as 1, so y would be 3, 1 square plus 5, which would be 8. But if I change x as 2, right? So if I change x as 2, so this would be y would be 2 squared 12 plus 5, 17. Right? This would be y2. So if I change x, so my y would also change. Right? Is that clear, guys?
Yes, sir.
So the
Yes, sir, it is
differentiation, we
clear.
have this, yeah, so we have this differentiation. This is an operation, just like addition, subtraction, and other thing. We have this operation differentiation, and this is defined like, so this is defined like dy by dx, right? So differentiation, this is called as differentiation of y with respect to x, right? So what does it tell, right? What does it tell? So let's say that if you want to calculate the change in y, right? So you guys understood that this y is a function of x. And if I change x, so let's say change in x would be delta x, which is x1 minus x2. Or let me write it as x2 minus x2. Right. And similarly, your y will change. So this will become y2 minus y. Right. So if I change delta x, so your y will also change. It will change to y2 minus y. So initially, let's say that let's say this is some y is equals to fx, right? This is fx, and this is x. So this is some y. And let's say that at this point, this is some x1 and this is y1. And this is some x2, and then this is some y2. Understood, guys?
Yes, sir.
So this point would be how much? This would be y2 minus y1, and this point would be x2 minus x1, right?
Yes, sir.
So if I calculate the ratio, so this is also called delta y, and this is also called delta x. So delta y by delta x, this is the change in y with respect to x. Is that clear, guys?
Yes, sir.
And if I calculate this change in very adjacent to this x1 value, right? So if I calculate the change at a very near point of this, right? So that would be limit delta x tends to 0 and delta y by delta x. So this is called the differentiation. A very little change in y with respect to x. Understood? So this was the delta x, right? And if so this is so this is x1, this is x2. This is the change in x1. So this is change in x1 and x2. Right, guys?
Yes,
And
sir.
if I bring this change to a very smaller one, so if I calculate the change very adjacent to this x1 point, I am calculating this change and I'm keeping this change very closer, so very close. I'm calculating the change very closely. So that will give you the change in y, right? So the ratio of change in y with respect to the x, and this change in x is very small. So this is called the differentiation of y with respect to x. Is that clear, guys?
Yes, sir.
Okay, so yeah, so we have now we have this special cases, right? So let's say that y is function of x, right? So let's say that y is a polynomial function. Polynomial function, polynomial function like this. Let's say x square or x cube, or let's say x 17 or x 18. So these are all polynomial function, right? And this one also, x cube plus 3x square plus 2x, right? Like this. So these are some polynomial functions, right, guys?
Yes, sir.
Yes.
So yeah, so I will just directly write what are the rules for the differentiation of these kind of functions. So what would be d by dx? So this is the differentiation operator. And this you will guys also learn in your mathematics portion. So I'm just talking about those portion which you will need in this physics part. So this is the differentiation operator, right? And let's say you have this function y. So you operate this d by dx to this y, right? This d by dx is not multiplied with this y. This is some operation, guys. This is differentiation operation. So this is an operation. Change in y with respect to x, very small change, right?
Yes,
Yeah.
sir.
Yeah, so you have some certain rules. So for polynomial is represented by this xn, right? So what would be d by dx of xn? This would be simply n xn minus 1, right? So let's say that if I want to calculate d by dx of x cube, so that would be how much? What is my n here?
1.
N, x to
Oh,
the
3.
power n, 3. So this would be simply 3 x 3 minus 1. Is that clear, guys?
Yes, sir.
So this would be simply 3x square d by dx of x cube. Is that clear, guys?
Yes, sir.
Okay, so if I want to calculate d by dx by dx of, let's say, 5. So this would be how much, Rishita?
So 5x raised to 4.
4. Right. So this is simple. Okay. Now let's say I have. So you guys, I quickly note down this part. So differentiation of xn. You guys, I quickly note down this part.
Finish, sir.
Okay. So yeah, and let's say that if I want to calculate the differentiation of, let's say this is k and y. Okay. So k is constant. So differentiation of this would be simply k and dy. Yeah. Yes. Did you ask? So did anybody ask something?
No, sir.
Yes.
No, sir. Nobody asked anything.
Let me, okay, before I do that, let me write the properties of differentiation. Okay. So first is this multiplication. So if I multiply, so if I calculate the differentiation of this k of y, so k would come out and this would be simply dy by dx. Okay. And second property is if I want to calculate d by dx of two functions. So let's say this is u, right? ux plus vx, two functions. So this would be simply du by dx plus dv by dx. Similarly, if I want to calculate the subtraction, so this would be minus. So let us understand these two properties with this question. So let's say that my y is 3x squared. Okay. So I have this function x squared and this constant term is 3 multiplied with this. So what would be my d by dx? So this would be 3x squared, right? So I can take this 3 outside. So this would be d by dx of x squared. So then this would be simply 2 and x2 minus 1. So this would be 6x. Is that clear, guys?
Yes, sir.
And let's say I have this y as 6x cube. Oh, before I do that, let me ask some question to Afaf. So Afaf, you tell me that I have this 2x5. So what would be my dy by dx? Afaf? Yes, Afaf. Yeah. Afaf, are you there? Yes, Afaf. What happened? Any doubt do you have? Okay. Can anybody hear me properly? So am I clear? Am I audible, guys?
Yes, sir.
Yeah, because Afaf is telling that I'm not audible clearly. So Okay, Akib, you tell me what would be differentiation of UX5?
Sir, 2 dx5
Is higher. Yeah,
by
by
dx
dx.
is equal to
So yeah,
2 into 5x 5 minus 1 power.
yeah, 4. So this would be 10x4. Absolutely correct. So now you guys understood about this property, this multiplication. Okay, and
Yes, sir.
similarly, yeah. So you guys note down these properties. I will talk about more, but you guys first note down these two properties. Yeah, whenever you guys note it down, please tell me. Then I can go ahead.
Finish, sir.
Finished. Rishita and Afaf finished.
Yes, sir.
Yeah. So what do I mean by this property, u plus v, or minus? So let's say that I have this y, which is 3x square plus 2x. Right, or let me write it as this one. So x5 plus x cube. Right, so I have two functions which are added together. So if I want to calculate d by dx of this function, so this would be d by dx of whole. Right. So from this property, we can take the differentiation of individual terms. So this would be simply d by dx of x5 plus d by dx of x cube. So this would be simply 5x4 and this would be simply 3x squared. Is that clear, guys?
Yes, sir.
Yeah, so this is about this property. Okay,
Sir,
and
can you scroll up little bit?
yeah,
Yes.
so I'm going fast. I want to quickly finish these differentiation and
Sir, it's done.
integration,
You can continue.
and then yeah, so then I want to relate it with physics. So why this differentiation and integration is important in physics. So we'll talk about that, and then I'll start this first chapter. Yeah, so this is about this addition, and let's say that let me ask you this question. So you have this y, which is 4x cubed plus 2x squared. So Akib, you tell me what would be dy by dx.
dy by dx.
Yeah,
D, then in bracket x cube plus x square.
x cubed plus, but where these 4 and 2 went? Yeah, so let us,
Or else
yeah,
we
let
can
us
write
do
like this,
it
right?
part by part. Yeah, let us do it part by part. So this is 4x cubed plus 2x squared. Am I correct?
Yes, sir. Sir, or else we can do like this. dx4 by dx.
So now you see that you have two terms, two functions. So we can write it as d, yeah. And is that correct? Okay.
Yes, sir.
Yes. So now we can use the first property there. So this 4 comes out, and this is d by dx of x cubed. And from here 2 comes out, and this become d by dx of x squared. So this would be simply 4 and 3x square plus 2 into 2x. So this would be 12x square plus 2x. Right, so this is dy by dx. Is that clear?
Yes, sir.
Yes. Yeah, so you guys quickly note down this part, and then I will do, so we'll do so many questions. So we will practice first and then we'll do it. So until and unless you guys get a good hang of these type of differentiation, then we'll do it. You guys quickly note it down.
Finish, sir.
Finished. Rishita and Afaf, finished.
Yes, sir.
Okay, so for Rishita, you tell me that this is, so what is dy by dx?
Sir.
Yes.
Sir,
Rishita.
one minute, sir.
Okay, okay. Sure, sure.
Sir, minus 3 by x raised to 4.
Okay, I got disconnected somehow. Am I audible, guys?
Yes, sir, you're
Yes,
audible.
sir.
Oh, so Afaf, you got disconnected, then I got. So yeah, Rishita, did you
Yes.
say this answer?
Yes, sir, minus 3 by x raised to 4.
Okay. So Akib and Afaf, did you guys understand how this answer came? Yes. Did you guys
Sir, I'm having doubt.
understand?
Yes, sir, I
Oh,
understood.
yeah, you understood. Yeah, Akib, what is your doubt?
Like not here, the previous question.
Oh, previous question. Okay, so why didn't you tell me earlier? Yes,
Sir, just like how we wrote here in
yes,
bracket 4x cube plus 2x square.
yes,
Instead,
yeah,
can we write d x4 by dx means dx? Yeah, dx4 by dx.
Sir,
dx4
d
by
by
dx.
dx is the formula, dy by dx is d by dx into x power n, right? The formula?
Yeah, yeah.
Okay.
So yeah, so why, where this x4 comes? Where is that x4?
Sir, because of 4x cube, right?
Yeah. So 4x cube, so we have d by dx. Hmm. Yes, exactly.
Sorry, sir.
Yeah, how can this be x to the power 4?
Sir, because we were using formula nx n minus 1, right? So if we wrote
Yeah,
4x,
so
4
this
minus 1,
is,
it will be 4x to the power 3, right?
yeah, yeah. So that would be the differentiation. This is the differentiation of x4. So differentiation of this would give you 4x cubed,
Yes,
right?
sir.
But do we have this differentiation of x to the power 4? We have this differentiation of 4x cubed, right?
Yes, sir.
You can obviously write 4x cube as d by dx of x4. So does it solve your answer? You have two differentiation, right? This would be d square x4 by dx square. So double difference. This is called the double differentiation. We will talk about this later, but we have to find the solution of d by dx of this, right?
Yes, sir.
We would not want to complicate this further. We want the solution of this part, right?
Yes, sir.
So obviously this is dx4. So yeah, so we have to solve this, not complicate this thing, right?
Okay, sir.
So by using the first property, this is 4, so this is a constant, so we can take it outside, right?
Yes, sir.
We can take it outside and then we do the differentiation of x cube. So then we'll get the differentiation of this 4x cube. Is that part clear? Okay.
Yes, sir. Clear.
Yeah. No. Any confusion you can ask again. So you can ask again if you have any confusion.
No, sir.
Okay. So yeah, let us come to this question. So did you understood that how we will get this 1 by x cube differentiation would be this? How do we get this result?
No, sir.
Yes, okay. Is that okay? So this power is in the denominator. So how can we write 1 by x cube? We know about this formula only, right? This is nx n minus 1. So we have to write
Yes, sir.
any terms in the power of x. So 1 by x cube, we can write, we can take x in the numerator. So this would become, power would become what?
X cube. X
Oh, this
minus
is
cube.
this minus 3, right? So yeah. So, and if we want to calculate the differentiation of this, so this would be d by dx of x to the power minus 3. So now what would be this? Okay. N is how much?
N is minus 3.
So this would be minus 3 and x to the power minus 3 minus 1. So minus 3
Minus
x to
4.
the power minus 4. So again, we can write it in the denominator. So this would power become positive. So x4. So that is what Rishita was saying.
Okay, sir.
Yeah, please note it down. Okay. And
Yes, sir.
Rishita has already, okay, so Rishita has already solved. So yeah, Afaf and Akif, you guys please note it down.
Finish, sir.
Finished. Okay.
Finish.
Yeah, and then we have this third property, which is d by dx of a constant term. So this is 0, right? D by, so let's say that if I want to calculate the d by dx of 3, so this would be 0. Is that clear, guys?
Yes, sir.
Yeah,
Yes, sir.
so yeah, and how this would be 0? So d by dx, and 3 into, we can write x to the power 0. Okay, so let us not do this. Okay, we will understand about this later. So just remember that the differentiation of a constant term is 0. Okay,
Okay, sir.
so
Okay, sir.
you guys can think of this way: xn, and when you put n equals to 0, so what would be the answer? N equals to 0, so what would be the answer? You guys think that way. Okay. So,
Okay,
and
sir.
the fourth property is differentiation of a division. So, u by v. So, this is u dash v minus u v dash, right? And this is v square. So, u dash, where u dash is du by dx, and v dash is dv by dx. So these are the 4 basic properties that we will use. Right. So please write this third and fourth property, guys.
Finish, sir.
Finished. Fourth one also.
Yes, sir.
Sir,
Okay.
one.
So yeah, Rishita and yeah, Afaf, you also finished.
Yes, sir. Finished.
Okay. So now let us do this
Sir, I did
problem.
complete.
Let's say why. Oh, you didn't complete. Okay. Sorry about that. Sorry about that.
Okay, sir.
Okay. So let me do this problem, that y is let's say y is what, 3x square plus 2 divided by, not yeah, let's say 2x plus 6x cubed plus 4, not 4, but let's say 5, right? And let us simplify this. So this is the question. Okay, guys. And this is in which form? Yeah,
Third,
this is in, yeah, this is in which form?
third property form.
Fourth, u by v, right?
Okay. Yes, sir.
Oh, but before that, I forgot about, oh, sorry. So before this property, this should be a multiplication also, right? So write fourth one. This is fifth. So you have this d by dx of u into v, right? U into v. So this is simply u dash v plus u v dash. Just right before this one. Okay.
Okay, sir.
Yeah, just write this one.
Finish, sir.
Finished. Rishita and Afaf finished.
Yes, sir.
Yes.
Okay, so already the time is over. So let me give you guys some question before we end the club. So this is 1, and let's say this is y is 3x square plus 4x plus 5, and 3 is y is equal to 2x 5 plus 6x square divided by 2x cube plus 7x